right, hey guys, it's Miss Lastly and Miss Marker. We're here for day number 18, and today we're going to talk about combinations. Take it away, Miss Marker.
Yes, so today we were talking about combinations, and they're very similar to yesterday. The formula for today is going to look very similar to something you had last week. Actually, it's going to look exactly the same because it is exactly the same as to what you had last week. So let's just jump right in. So a combination is just like yesterday with the permutations. It's an arrangement of objects the big difference from yesterday, so yesterday with permutations, order mattered. So when you had the horses running in the race, it mattered who came in first, second, or third. The difference today is that order does not matter. So for a combination, order does not matter. So that is the big difference between permutations and combinations. With a combination, order doesn't matter. With a permutation, the order of the objects does matter. So your formula for combinations is that factorial piece from your binomial theorem. So it's n factorial over n minus r factorial, r factorial. And this is equal to n choose r, because you're taking out of the number of objects you have, you're choosing a certain number of them. So n equals the number of objects that you have and r equals the number of objects that you are selecting. And to do this in your calculator, it's the same thing as last week. It's math, and then you scroll over to the prob little piece, and then it's just number 3. Remember that old calculators, you have to put n in first. New calculators, you're going to end up with the 2 little boxes on either side. But it's just the same as last week, so I'll just write it over here for you guys, but it's the same as last week. Prob, and then just the number 3 option. Cool. Just like that. So yeah, okay. So let's just do a quick example, and then I think I'm gonna go over one from the homework just as another example, and then I think that will be it for today. So again, we have 8 horses running in our race. If the top 3 horses move on to the next round, how many different 3-horse combinations are there? So out of the 8 horses, how many different combinations of 3 horses can move on to the next round? So for this one, we're going to take n is equal to 8, because that's the total number of horses that we're choosing from. And then the top 3 move on. So r is going to equal 3 because you're only selecting 3 horses. And from there, you're just going to have the 8c3, and you can plug it into your formula and do it visually, or so we would have 8 factorial, 3 factorial, and then this would just equal 56. So there's 56 different combinations of horses that you could have moving on to the next race. Not too much harder than yesterday. I kind of think these are nicer because order doesn't matter, so you kind of don't have to think as much. But yeah, anything to add, Miss Lastly?
No, combination is pretty straightforward. The only thing that does get a little challenging, and I'm sure some of you probably are already guessing this, but tomorrow we're going to do like a mix where we have combinations and permutations all mushed together. So you really have to ask yourself, like, does the order matter? So yesterday we talked a lot about finishing first, second, or third, or I don't know. Those were like the main one, finishing first, second, or third, right? Well, this one doesn't care if you finish first, second, or third. It's just saying the top 3 move on. So it doesn't matter where you place in the top 3. So basically, if you're thinking of this as like letters in the alphabet, right? So if we have 8 horses, we have what? A, B, C, D, E, F, G, and H. So if A, B, and C finish first, second, and third, it's the same top 3 as if B, A, and C finish in the top 3. Like it doesn't actually matter out of the top 3 who's winning. It just matters the top 3 move on. Whereas yesterday we were more focused on, if A comes in first and B comes in second, that's different than B coming in first and A coming in second. So with permutations, right? So what Miss Marker just wrote, so ABC equals BAC. So in combinations, those count as the exact same thing. They don't get to count as something separate. Whereas with a permutation, ABC is different than BAC. So they get to count twice. So that's what we mean by order matters versus order doesn't matter, right? So you just want to ask yourself, like, does it really matter the order that people finish in, or is it just important that these people finished? Because combination just matters that they finished, whereas a permutation, the order in which they finished is important. So a lot of times, like permutations, if you're making a batting lineup, right? For those people who know anything about baseball or softball, the order that you bat is important. Batting first is different than batting ninth. But combinations would just be something like, what are the 9 players that are going to play today? So if you have a team of 15, which 9 are your starters? That's a combination, still talking about baseball, softball kind of lineup, but it's just different types of problems, right? So combination doesn't matter the order you pick people, whereas permutation, the order in which you pick them is important. So that's just the main thing to remember. Tonight's homework is only focusing on combinations, so you can just kind of practice what those problems look like. But just know that tomorrow we are going to mix them, so you can see, you'll have to kind of distinguish which one counts as combination, which one is permutation. And the main thing to ask yourself is, does order matter, or is the order irrelevant?
And you will have to do that on your checkpoint too. We're not going to be nice and tell you what's what, because why would we do that?
Why would
I should know better. Yes. Okay, let's do one example from the homework, and then I think we're done for today. These aren't too bad. Let's do number 5. Number 5 looks like fun for whatever reason. Okay. So the lottery requires winners to pick 6 integers between 1 and 46. The order in which you select the numbers does not matter. So this right here automatically tells me that I'm dealing with a combination if you were to have a mix. So as soon as it says order doesn't matter, you're dealing with a combination. Now, obviously on tonight's homework, it's all combinations, but that's a good way to just know that it's a combination for tomorrow's stuff. Lottery tickets are always printed with the numbers in ascending order. How many different lottery tickets are possible? So it said that we had integers between 1 and 46. And so we know that we have 46 total numbers that we're picking from. Now, the number of letters that we're picking is 6. And so R is going to equal 6. So you're picking 6 from the 46 letters that are available. So you're just going to take 46, you're going to choose 6, and then this is equal to 9366819. And that is how many different combinations you have of 6 letters of that 46, and that's it.
I think N might be 47 though.
Oh.
Because if you count 1 and you count 46, 47. Just be careful with those ones. They're trying to trick you, right? So if you can pick numbers 1 like through 46 as your lottery numbers, you technically are allowed to pick 47 numbers. Like there's 47 numbers to pick from.
Yeah. Cool.
I think so.
Yeah. I don't know. I think so.
Well, let's see. If you can pick numbers 1 through 10.
you have 1, 2. No, I think it's 46. I think it's 46.
Okay, 46. Maybe I'm
I
overthinking.
think it's 46. I think if you had 0 through 46, it would be 47, but I think it's 46.
Okay.
I'm pretty sure it's 46.
No, guys, maybe I'm overthinking this.
Well, because if you have 1 through 10, you only have 10 numbers to pick from.
Yeah, that's true. You're right. 10. It's 10 numbers. Okay. All right. 46.
Cool. 46. Final
That's
answer.
the right answer. Right answer. Final answer. Lock it in.
Okay, that's all I have for you guys. If we got that wrong, let us know and I'll go fix it. But we're gonna stick with 46.
Who knows? I think it's probably right. I think it's right. I think it's right. I don't know why I want to add 1 extra. It doesn't matter. It doesn't matter. It's fine. Okay. All right, guys. Well, that is it for today. Hopefully you enjoyed that fun little talk through problem number 5. I think we did. I think you're right. I think 46.
I think it's 46.
46. Okay, we will see you guys again tomorrow for our live stream. I don't think we're going to do, are we going to do a notes video tomorrow?
I don't think we need to. If you guys want one where I talk through kind of how to tell between permutations and combinations, let me know and I'll do that while Miss Lastly sets up the live stream. But if not, probably not.
Cool. All right. Well, we will see you guys at least tomorrow during the live stream. Hope this has been a pretty good week for you guys. I don't think it's been too tough. Let us know in the discussion boards if you have any questions. And yeah, we'll see you tomorrow.
Make sure you're posting in this week's discussion board though, because I don't always see if you post in some other discussion board because it's not this week. So make sure you're posting in this week's.
Cool. All right. Bye, guys.